Hey, I'm Andrew Vaziri, captain of Team Space Slam Robotics. 3 months ago, I quit my first job out of college to be an intern at a robotics company. That internship is almost over now. We've got like 10 days left, but in that time, I've met a lot of great people who were inspired as kids watching Battlebots, and together we have decided to do something unprecedented. We are going to make the first self-driving Battlebot. Now let me set the stage. We have a problem nobody else has. We have to integrate sensors into our robot so that it can lock onto the enemy, but we have to put them somewhere where they're not going to get damaged, where our own weapon isn't going to get in the way, and we had to go back to the drawing board time and time again. Eventually, Eric, our mechanical engineer, came to me and he said, this is it. This meets everything we needed to meet. And I looked at it and my first thought was, our robot is wearing a top hat. Like, who is this? Abraham Lincoln? And so it was.
Hi, I'm Eric, mechanical lead.
This is Honest Abe, a self-driving robot wrecking machine. There are 3 major pieces to the robot: the shell, the chassis, and the top hat. On the inside of the robot, the chassis holds all of our key components, like our onboard computer, our 4 drive motors, and our giant weapon motor. In total, these motors put over 34 horsepower. That is more power per pound than a brand new Corvette. How does our robot know where to go? Inside Honest Abe's top hat, there is the laser distance scanner. That sensor takes 5,400 measurements each second.
Hi, I'm Jackie Kay, lead software engineer. This is a simulation we use for testing the robot software. The blue rays visualize the robot's vision. When an enemy robot obstructs the rays, Abe can detect it and use that information to drive forwards for a killing blow.
10 years ago, making a self-driving BattleBot like this would have been impossible without the budget of a NASA or an MIT. But in those 10 years, we've had smartphones. They've made the demand for cheap, compact, powerful electronics skyrocket. But that alone isn't enough. You need software to tie it all together. Software that can read from sensors and understand the environment of the robot, make an intelligent plan and execute that plan. That's what we do here on a daily basis. And we're going to apply that expertise to BattleBots. Now, when we get in the arena, we're going to have something to test. The first 250-pound self-driving BattleBot. We're explorers of BattleBots, regular Ferdinand Magellans. But unlike Ferdinand Magellan, we're not going to die of a stab wound in the Philippines. We're going to win. But you might be asking, what do these computer nerds know about raw, metal-crunching power? Let's show you our training regimen. I'm not talking about these silly weights. I'm talking about strategy. Advanced tabletop role-playing. Professional trading card games. And chess.
Checkmate.
But we know how to build BattleBots. For your viewing pleasure, Aaron, the current DragonCon champion, versus Eric, multi-time RoboGames champion. Move along, move along. As you can see, we don't take ourselves too seriously, but we do take winning seriously. Because from here on out, you're not going to need just a smart team. You're going to need a smart robot. Our robot can do hundreds of billions of calculations each second. From the looks of our competition, some of them haven't done a single calculation during the entire design of their robots. Aaron, Zoe, let's roll out.